Hello, good morning student. How are you? I hope you all are happy, healthy and fine at home. So what did we discuss yesterday? We discussed about the effect of living group, and as we know that the living group, good living group or the poor living group, good living group always increases the rate of SN2 reaction, whereas bad living group decreases the rate of SN1 reaction. So that type of the thing, and there are 3 sub point we have discussed. So today what we are going to discuss, we are already learning or discussing the chapter number 3rd. Name of that chapter is nucleophilic substitution at aliphatic carbon. Here is the effect of nucleophile, and as we know that, what do you mean by the nucleophile? We know that nucleophile are the electron rich species. It has the ability to donate the lone pair to the other atom according to as a Lewi's basis. They carrying negative charge or maybe sometime neutral molecule containing as a lone pair of electron. That type of the species are known as a nucleophile, and nucleophile playing important role in deciding whether the following reaction will follow SN1 mechanism or SN2 mechanism, because there are 4 factors. First factor, the effect of structure of substrate. Second one is the effect of nature of living group. Third one is the effect of nucleophile. If you remember the SN1 reaction and the SN2 reaction, SN1 reaction, the nucleophile participate in the rate determining step, means in the slow step, and therefore the nature of nucleophile is deciding whether the SN1 reaction, rate of SN1 reaction increases or decreases. That is depending upon the concentration as well as nature of the nucleophile. But in case of the SN1 reaction, because SN2 reaction is a 2-step reaction. First step is a departure of the living group, rate determining step, and the nucleophile participating in a SN1 reaction in the second step, and that second step is a very fast step, and therefore SN1 reaction does not depend upon the concentration of the nucleophile as well as nature of the nucleophile, and therefore remember here only the nature of nucleophile decided the concentration, and the nature of nucleophile decided the what we can call it as whether the following reaction follows SN1 reaction or the SN2 reaction. If there, and as we know that nucleophile and the basicity both are negatively charged species, as well as the species containing lone pair of electron, both are same in terms of they are electron rich species, they are negatively charged species, or they are containing as a they are the neutral molecule containing lone pair. They are called as a nucleophile as well as basis, and the basicity is base strength is measured in terms of the basicity, whereas nucleophilicity is determined or measured in terms of their nucleophilicity. Both are the same, but there are some major differences between basicity and the nucleophilicity. Remember, base is a first major difference between nucleophilicity and the basicity. Remember here, first major difference between the basicity and the nucleophilicity. First, base. Remember, base is a substance which can donate the lone pair lone pair of electron to the H plus is known as basicity, whereas the substance which donate the lone pair of electron to the other atom of one carbon is known as a nucleophilicity and to form a covalent bond. Remember, this is the first distinguishing point between basicity and the nucleophilicity, right? First major difference between basicity and nucleophilicity. Basicity and nucleophilicity. Nucleophilicity, right? Nucleophilicity. Basicity means what? It has the ability to donate the lone pair to the H plus ion is known as basicity, whereas nucleophilicity is the organic species having a ability or capacity to donate the lone pair to the carbon atom, that is known as a nucleophilicity. Right? This is the first major difference between basicity and the nucleophilicity. Now second difference between basicity and the nucleophilicity, basicity is controlled by a thermodynamic factor. Basicity is controlled by a thermodynamic factor, whereas nucleophilicity is controlled by a kinetic factor. This is controlled by kinetic factor. So this is a second one is a major difference between the basicity and the nucleophilicity. This T stand for thermodynamic factor, means thermo means heat and here K means rate of reaction. Kinetics are there involved and that's why it is kinetic. And third major difference between basicity and the nucleophilicity is that, what is that? The basicity where nucleophilicity get affected by the steric effect. The steric effect, this is greatly affected by the nucleophilicity, but basicity does not affected by the steric factor. Means steric factor affect the nucleophilicity, whereas basicity does not get affected by the steric factor. So these are the three main differences between the nucleophilicity and the basicity. So understood this one. Now there is a criteria for nucleophiles, and this is a very important point we are going to discuss over here. Criteria for nucleophiles. 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 There are some criteria for nucleophiles. Following are some general criteria to decide whether a given reagent is a good nucleophile or not. So there are certain criteria are given here. Here we are going to discuss. I think there are 4 criteria are there. First criteria, a negatively charged species is more nucleophilic than neutral molecules. What is that? First one is a negatively charged species. A negatively charged species. A negatively charged species. Negatively charged species. Negatively charged species are more nucleophilic. Negatively charged species are more nucleophilic than negatively charged species are more nucleophilic than neutral molecules. Similarly, negatively charged species are more basic than the neutral molecules. Here, remember, negatively charged species are more nucleophilic than neutral molecules, and remember here the negatively charged species, charged species are more basic than neutral molecules. This is additional point I am discussing over here. Remember, negatively charged 2 mark question or 3 mark question always appear on this criteria number 4 on the basis of that criteria. So remember, this is a very important concept. Once you understood, it's very easy to explain or give the justification, or you can answer the question very easily if you understood this concept. A negatively charged species are more nucleophilic than neutral molecules, or what you can remember, negatively charged species are more basic than neutral molecules. One and the same thing, because they are nucleophilicity and the basicity correlate to each other. Now look at here, suppose I have first example OH minus and another one is water, right? What do you think? Which one is a more nucleophilic, or this is, as we know that this is a negatively charged species, and water, you know that it is a neutral molecule, and therefore according to this statement, negatively charged species are more nucleophilic than a neutral molecule, and therefore mathematically you can show the symbol, it is more nucleophilic than this one, and that's it. And suppose as a basic, negatively charged species are more basic than neutral molecule, same OH minus is more basic than the water molecule. That's it, so simple. Now let us look at here, suppose we have another one, NH2 minus, and what we can call it as here another one. There is ammonia. Ammonia, everybody knows that it is a neutral molecule. Negatively charged species are more nucleophilic than neutral molecules. Remember, this is a negatively charged species and this is a ammonia is a neutral molecule, and therefore definitely it is a more, amide is a more nucleophilic than ammonia, or on the basis of basicity, NH2 minus is more basic than the NH3. Remember, now suppose I have another example, OR minus, and what we can call it as a ROH. Let us look at here. It is alkoxide and it is a alcohol. Alcohol, as we know that it is a neutral molecule, and this is a more nucleophilic than this, or it is a more basic than this one. Understood this one? Negatively charged species are more nucleophilic than neutral molecules. And now let me suppose OH minus and second one is a NH2 minus. Now tell me, remember this one, OH minus and NH2 minus are there, these two are there. Now tell me, among these two, which one is a more nucleophilic or which one is a more basic in nature? What do you think? Whether OH minus is a more nucleophilic or more basic, or NH2 minus, what do you think? Here remember, here NH2 minus and OH minus, NH2 minus is a more basic than this one. Remember why? Because oxygen, now here oxygen atom is a more electronegative than the nitrogen atom. You know that. If you see the second long form of the periodic table, the elements belong to the second period are lithium, beryllium, boron, carbon, nitrogen, oxygen, fluorine, like this, because they are second group consists, and therefore oxygen atom is a more electronegative than the nitrogen atom, and therefore due to the more electronegativity, it holds the electron more tightly as compared to the nitrogen atom, and therefore OH minus is a less basic over NH2 minus, or NH2 minus is a more nucleophilic. This NH2 minus is a more nucleophilic than OH minus. Remember this. Suppose let us see here, I have drawn NH3 and the water molecule. What do you think? Which one is a more nucleophilic in nature, or which one is a more basic in nature? What do you think? Now you are very smart here. Look at here again. Here is ammonia and here is a water, and ultimately ammonia is a more nucleophilic than the water. Right? I am writing this one. Suppose in an exam they may change their position. This is 2 over there. Suppose here maybe as a, what we can call it as a, here H2O, and here is a ammonia. How do you show the arrow? Most of the students get confused. Here is this ammonia is a more nucleophilic or more basic in nature, and therefore we can show the arrow like this. Remember this arrow, this arrow clearly indicates that this is a more nucleophilic in nature than the water molecule. Understood this one, this theory? Now let me give another one more example. Suppose you have this one. Let us see, OH minus and OR minus. Now OH minus and the OR minus, which one is a more basic in nature? What do you think? Or which one is a more nucleophilic in nature? Which one? Whether OH or OR minus? Now remember here also OR minus is a more nucleophilic or more basic in nature than the OH. So in this way you can learn this one. Or suppose we have another one. Suppose we have a H2 water and another one is alcohol. Which one is a more nucleophilic in nature? Whether water is a more nucleophilic or alcohol is a more nucleophilic? Here remember again is a water, alcohol is a more nucleophilic over the water H2O. So I think with this you might have cleared the idea, and 1 mark, 2 mark or 3 mark question definitely appear on this. So remember, this is a negatively, only this statement you should remember. You must remember a negatively charged species are more nucleophilic than neutral molecule, or negatively charged species are more basic than the neutral molecule. Basicity in this case, in the first criteria, basicity correlate with the nucleophilicity, means both. Stronger the base, stronger is the nucleophile. Stronger the weaker the base, weaker is the nucleophile. That is the thing you have to remember over here. This is a criteria number 1 we have learned over here. Now let us look at as a next criteria. What is that criteria? If the attacking atom is the same. Second one, if the attacking atom is the same, if the attacking atom is the same, nucleophilicity increases with basicity. Nucleophilicity increases with basicity. If the attacking atom is the same, nucleophilicity increases with basicity. That means that stronger the base, stronger is the nucleophile. It means that stronger the base, stronger the nucleophile. Stronger the base, stronger the nucleophile. Stronger the base, stronger the nucleophile. Look at second criteria. On a second criteria also, arrange the following molecule or the compound on their either increasing or either decreasing. You have to arrange according to their strong basicity or maybe as a nucleophile. So they will give 2-3 examples. Remember here, if the attacking atom is the same, nucleophilicity increases with basicity, means stronger the base, stronger will be the nucleophile. So that is there. Now let us look at here some of the example. C2H5 O minus, this is alkoxide. Sometime it is a C2H5 is written as a CH-3 CH2 like this, CH-3 CH2O minus, that or this one and the same, these or these are the same, that is a ethoxide. This species is pronounced as a ethoxide, or this species is known as a ethoxide. Then let us see here another one. I am writing over here, this is O minus, this is a phenoxide, this is ethoxide, this is a phenoxide. Let me draw another one, CH3 C double bond O minus, that is a acetate ion, and the last one is a NO2 minus. Look at here, NO2 minus means here the attacking atom, normally here NO minus double bond O, here you can write like this, means attacking atom, consider here is oxygen atom, here also oxygen atom, here also oxygen atom. According to our statement, what is the statement? If the attacking atom is the same, look at here, oxygen, 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 oxygen everywhere is there. What do you think about the nucleophilicity? Nucleophilicity correlate with the basicity, means basicity increases, nucleophilicity also increases. Now which one is more among these? I am specifically written, which one is more basic in nature, do you think? This one is more basic in nature than this, and this is the weakest one. Means as we go from this side to this side, what is going to happen? Nucleophilicity goes on increasing or decreasing, or the basicity first? Basicity goes on decreasing, this, because it is the strongest one. Basicity decreases, basicity decreases. As we move across this blackboard, or as we move from left hand side to right hand side, basicity goes on decreasing. And now the nucleophilicity is the same. Nucleophilicity will show the same trend, means the nucleophilicity also goes on decreasing here. Nucleophilicity decreases as we move, means it is a strongest nucleophile, or what we can call it as the strongest base among these 4 species. This is all about the criteria number 2, right? Now let us move on to the next one, that is the criteria number, what is the criteria number 3rd one? Criteria number 3rd one, what is that? When attacking element, when attacking element belongs to the same period, when attacking atom belong to the same period, attacking to the same period, same period of the periodic, same period of the periodic table, periodic table, then the nucleophilicity correlate with basicity. Then nucleophilicity correlate with basicity. Correlate with basicity. Look at here, criteria number 3. When the attacking element belong to the same period of the periodic table, then nucleophilicity correlate with basicity. Means as we know that belong to the same period, as we know that in the periodic table there are 7 horizontal rows is known as a period, and there are 18 vertical columns are known as a group, as we know that. Now in the periodic table, and for example, suppose let us see over here some of the example here. H2O, water molecule, and the let us see here ammonia, NH3 again, NH3, right? When attacking element belong to the same period of the periodic table, then nucleophilicity correlate with the basicity. Now look at oxygen atom and nitrogen atom, they are present in the same period, as we know from left hand side, lithium, beryllium, boron, carbon, nitrogen, oxygen, fluorine, right? Fluorine, like this. 1, 2, 3, 4, 5, 6, 7, right? And now 1, 2, 3, 4, 5, 6, 7. 5 p block element and 2 are the s block element. Let us see. And as we know, lithium has a 3, 4, 5, 6, 7, 8, 9. These are the atomic numbers of these elements. And now here oxygen atom and nitrogen atom. Now nitrogen atom is more less electronegative than the oxygen atom, right? Because oxygen atom is the nearest to the fluorine atom. Fluorine is the highest electronegative element present in the periodic table, and therefore here NH3, ammonia, is more basic than the H2O. Similarly, if you have a OH minus, is less basic than the NH2 minus. Basic are the means basicity as well as nucleophilicity correlate with this. So that is the answer here. Over here, when attacking element belong to the same period of the periodic table, then nucleophilicity correlate with the basicity. That is the criteria number 3. Let me clean the board first over here, and now the criteria number 4th, and which is a very important one. Most of the questions appear on it, and therefore it is a important one. Fourth criteria. What is that? If the attacking atom belong, if the attacking atom belongs to the same group in the periodic table, the same group in the periodic table, same group in the periodic table, nucleophilicity does not correlate with basicity. Remember, nucleophilicity does not correlate with basicity. Does not correlate with basicity. Remember why this one. If the attacking atom belong to the same group in the periodic table, the nucleophilicity does not correlate with basicity. Why this so? Let us see here order of basicity. And now order of nucleophilicity. Nucleophilicity, right? Now let me give some example here. Suppose we have fluorine, chlorine, bromine and iodine, right? And let us see here, suppose as a RO minus and RS minus, right? RO minus or let me properly draw these two groups, O R minus and S R minus, right? Now, if the attacking atom belong to the same group in the periodic table, nucleophilicity does not correlate with the basicity. Now we have written here order of basicity, which one is more basic in nature. Here fluorine atom is more basic than the chlorine than the iodine, right? This is a basicity order, but in case of the order of nucleophilicity, it is exactly reverse. F minus, Cl minus, Br minus and the I minus. In this case, this is the order, means I minus is a more nucleophilic than the fluorine in this case, because order of basicity and the order of nucleophilicity, they are not correlate to each other. Nucleophilicity does not correlate with the basicity, and therefore now look at here, OR minus and the SR minus. Which one will be the more basic in nature? Here OR minus is more basic than the SR minus, because as the size of those atoms are smaller one carrying as a negative charge, they are basic in nature. Look at here, fluorine is the smallest one and therefore it is more basic in nature, and I minus is a bigger and that's why it is a less basic. But nucleophilicity is exactly reverse over here. Order of nucleophilicity, here I minus is a more nucleophilic than the F minus. Similarly over here OR minus and the SR minus. Which one is a more nucleophilic in nature? What do you think? Remember here is a twist. Most of the time this type of the question appear in the exam. Here remember sulfoxide is a more nucleophilic over the alkoxide. Sulfur is there because as we know that oxygen family member, here oxygen, sulfur, selenium, tellurium, polonium, these are the family members are there. So as we move from top to bottom, the size of that atom increases, and as the size of atom, as we go down the group, the periodic table, the size of the attacking atom increases and the electronegativity decreases. As we know that across the period electronegativity goes on increasing. As we go down the group, the electronegativity goes on decreasing, and therefore as a result, the outer electron, valence electron are more easily polarized and initiate the bond formation even from a larger distance, and this makes the larger attacking atom more nucleophilic than the smaller attacking atom, and that's the reason why OR minus is a less nucleophilic than the SR minus. That is the reason. Now let us see one more example here, how that nucleophile changes the reaction path, whether the reaction follows SN1 mechanism or SN2 mechanism. The reagent with higher nucleophilicity favor the SN2 reaction, SN2 mechanism, whereas reagent with low nucleophilicity favor the SN1 mechanism. And for example, neopentyl bromide, for example, neopentyl bromide reacts with ethoxide, while ethoxide ion by SN2 reaction, ethoxide ion by SN2 reaction while to give the unrearranged to give the reaction to give the unrearranged product, unrearranged product, that is ethyl neopentyl ether, that is ethyl neopentyl ether, while with weaker nucleophile, like ethanol, CH-3 CH2OH, it gives the rearranged ethyl tertiary pentyl ether, pentyl ether by SN1 reaction, Why this so? Let us see over here. What is the structure of neopentyl bromide? This is the structure of neopentyl, CH3. Then let us see here CH3, CH2 and Br. Here ethoxide ETO minus attacking via SN2 reaction. What is happening here? This is a structure of neopentyl ethyl bromide. Neopentyl bromide, or we can call it as 1 2 3 2 1 bromo 2 dimethyl propane. That is a IUPAC name, but it is a neopentyl bromide. OH minus, it is a nucleophile. Is a concentration of nucleophile is a greater, and as we know that it is attacking from the back side, the resulting compound we are getting this one CH3. Then here a CH2 OET you can write here, or CH3, and this CH3. That is a unrearranged product, that is a ethyl neopentyl ether, ROR we know that, and that's why it is a unrearranged product. What is that? Ethyl neopentyl. This is ethyl neopentyl, that is the product we are going to get. We are getting over here. Now the last one, and now let us look at as a second one. What is happening? The first, as we know that this CH3, then CH2 Br, here CH3, the substrate is the same. What is the name of the substrate? Name of the substrate is a neopentyl bromide. This is a substrate, and here we are using as a solvent, right? Solvent we are using ETOH, ethanol. The reaction takes place via SN1 reaction. In the SN1, what is happening? First step is a departure of the leaving group, means the bond breaking between carbon and the bromine. We are going to get here CH3, then CH2, CH3 and CH3. Look at here, positive charge comes on the this carbon atom, that is carbocation. What type of the carbocation it is? What do you think? It is a primary carbocation. And as we know that the stability of the carbocation tertiary carbocation is more stable than secondary than the primary carbocation, and therefore there is a rearrangement takes place here. Rearrangement takes place over here. This one of the methyl group want to shift methyl group shift here, shift of methyl group, that is 1 2 shift, and we are going to get here CH3, then CH2, CH3, positive charge over here, and this one. Now if you observe this carbocation, what do you see? It is a tertiary carbocation, and as we know that tertiary carbocation is highly stable in nature because that positive charge get stabilized due to the due to the inductive effect, and now the ethanol is attacking. Now weak nucleophile ETO minus ETOH, this can attack either both the side, and you are going to get the product is this one, CH3, then CH2, CH3, then O, CH2, CH3, and this CH3. Name of this compound is a 1 2 3 4. So maybe as IUPAC name 2-ethoxide, 2-methyl, 2-ethoxy, 2-methyl butane, or we can call it as a this one, ethyl tertiary. This is a ethyl tertiary pentyl ether, tertiary pentyl ether. In this way we have completed the effect number, second effect of the nucleophile, and by knowing its concentration and the nature of that nucleophile, we can clearly understood whether the given reaction is following SN1 mechanism or SN2 mechanism. I think with this, let us stop today here. Fourth one we will see in the next lecture. Thank you. Have a nice day.